All right, guys, we are moving on today to objective 26. We are going to find values of trigonometric functions, using double angle formula. So, like if I say that I want to find the cosine of 2x, then basically what we're doing is we're taking that angle and we're doubling it, and we're finding that amount. Does that make sense? So like if I want to know the sine of 100 degrees and I want to find the sine of the double angle of that, basically I'm finding the sine of, what's double 100? 200 degrees. Does that make sense? Double that amount. And so we're going to use the double angle formula. So again, just more formulas. And the concept is write your formula down, plug your numbers in, work it out. Okay? And it will work it for you. So double angle formulas, here's the definition. Double angle formulas allow us to find the values of trig functions at 2 times their value of x. Okay, at 2 times their value of x. I know what some of you are thinking. You're thinking, okay, if I want to know 2 times that particular value, why don't I just find, like if it was 100 degrees, why don't I just find the 200 degrees and use what we did yesterday? So we're not going to give it to you in degrees today. I'm going to give you like the cosine is negative 4/5, and you are in quadrant 3. Does that make sense? And so what do you think you're going to be using when I tell you that? Well, we're going to go back to our all students take calculus, so you're going to have to pay attention to your signs. Does that make sense? You may have to use your Pythagorean theorem or sine squared x plus cosine squared x is equal to 1 to figure out what the other values are of sine and cosine. So it's kind of reviewing back to what we did, I don't know, a couple months ago, like towards the beginning. And so I'm not really giving it to you in degree format. If I did, you would just be able to double it and find that degree instead of using the double angle formula. Does that make sense at all? Not sure. All right. Everybody good? Okay, so here are your formulas. Check your formula sheet. See if they're on there. If they're not on there, they should be on there. You might want to box them in, highlight them so you know what you're looking at. So basically, when they say find the sine of 2x, this is how you're going to do that, okay? The sine formula, sine of 2x, you're going to basically take 2 and multiply the sine of x times the cosine of x. Okay? The cosine of 2x, you have 3 options to use. So which one do you pick? The easiest one. And we know that all of these, basically, if you use your Pythagorean identity, you know you can manipulate this to make each one of these equivalent, okay? So the cosine of 2x is equal to the cosine squared x minus the sine squared x, or you could use 1 minus 2 times sine squared x, or you could use 2 cosine squared x minus 1, okay? And it's up to you which one you want to use. They all should come out to equal the same thing, okay? And then the tangent of 2x is equal to 2 times the tangent of x divided by 1 minus tangent squared x. So I'll hit pause and let you take a minute and copy those down. Okay, I'm going to move on. All right, so I'm telling you for example 1 that the cosine of x is equal to negative 2/3, and we know we are in quadrant 2. And I'm going to ask you to find the cosine of 2x, the sine of 2x, and the tangent of 2x. Okay, so basically, how many problems do we have here? 3. Okay, we're just going to take one at a time. So let's first focus on the cosine of 2x. Yeah, I'll give you a second. Let's first look at what we have. Sometimes you've got what you need and you can just plug directly into the formula. So tell me, let's first try the cosine of 2x. So let's go to our formula sheet. You tell me what's the cosine of 2 times x equal to. Give me the formula. Oh, so this is the one that has 3 different ones. So let's think about that. What do I know? I know the cosine. Well, there's only one there that uses, you can use any of them, but the other 2 have what with them? Sines. So what would you have to do if you wanted to use the other 2? You'd have to use your Pythagorean theorem, sine squared x plus cosine squared x equals 1, and you'd have to figure out your sine first. But since we know our cosine, we've got a formula that just uses cosine. I would use that formula. So which one should we use? 2 cosine squared x minus 1. Okay, does everybody understand why I picked that one? Because we had the cosine, so now we can just plug directly in. So I'm going to leave the 2. I'm going to bring it down. Cosine, I know, is negative 2/3, and what do I need to do to it? Square it, because it's cosine squared, and then subtract 1. And then I'm just going to work it out. You need to square before you multiply, right? Don't multiply and then square, right? We're going to square first. So when I square a negative times a negative, what do I get? A positive. And square the 2 and square the 3, what do I get? 4/9 times 2 minus 1. You can put this in your calculator, guys, and do math enter. It'll work out for you. If I multiply this, this is going to become 8/9 minus 1. And then I know that is really 9/9 because that's what 1 is. So that's going to end up being negative 1/9. So I know cosine of 2x, if cosine's equal to negative 2/3, the cosine of 2x would equal negative 1/9. Did I lose anybody? Write the formula down, plug it in, work it out. Okay? And that's your answer for the first one. Any questions before I go to the sign? So I hear this seems really easy. Yes? No, it's not harder. I mean, other than the fact that you may have to use what we learned a couple months ago and then plug in and find other things. So let's go to the sine. Let's find the sine of 2x. Okay? What's our formula? Let's look and see what we're going to need. The sine of 2x is equal to, there's only one formula, so 2 sine of x times cosine of x. Well, let's look at it. I know the cosine is what? Negative 2/3. Do I know the sine? So there's a big question mark right there. So before I can plug into the formula, I'm going to have to go off and I'm going to have to figure out the sine. And you can do that using your Pythagorean theorem. Okay, we know cosine squared x plus sine squared x is equal to 1. So we can plug in negative 2/3 squared plus sine squared x is equal to 1. That's going to give me positive 4/9 plus sine squared x is equal to 1. When I move this over and subtract 4/9, I'm going to get sine squared x is equal to What's 1 minus 4/9? 5/9, just positive, because this will be 9/9. So 9 minus 4 would be 5/9. And then I'm going to take the square root of it. So our sine is equal to square root of 5/3. Now that could be plus or minus. Everybody agree? What's the square root of 5? Plus or minus 5, right? You with me? Could be positive or negative anytime you take the square root. It can be plus or minus, but the question is, how do I know which one it is? I'm in quadrant 2, so what do I know the sign is? So I'm going to use a positive eraser. I'm going to take away the negative, and I'm going to use a positive square root of 5/3. Any questions on how I knew to take the positive? You just use what quadrant you're in. Okay, and then we're going to work this out. So if I multiply, now this you cannot put in the calculator all at once because of the square root. Does that make sense? So basically this is 2/1, and what I'm going to do is I'm just going to multiply all this together, outside, outside, inside, inside. So what do I have on the outside? I have a 2 and a 2, so I'm going to multiply those together and get -4. Then I'm just going to bring down the square root of 5, and then 1 times 3 times 3 is 9. So I know that the sine of 2x is equal to -4 times the square root of 5 divided by 9. Thank you. Is your brother coming? Okay, so let's go to, let me erase, and let's go to the tangent. Okay, so what's our formula for tangent? So the tangent of 2x is equal to 2 tangent of x, 1 minus tangent squared. Okay, so, I know the cosine is -2/3. Do I know the sine? Okay, I found the sine is what? Square root of 5/9. How am I going to figure out the tangent? It is the sine divided by the cosine. So I'm going to do square root of 5/9. Oh, over 3. Thank you. And divided by -2/3. What do I know is going to happen to the 3's? They cancel. And so my tangent's equal to negative square root of 5/2. Yes, I can. I get trig happy, so just slow me down. All right. So we're going to plug in 2 times what? Negative square root of 5/2 divided by 1 minus negative square root of 5/2 squared. Okay, so let's simplify slightly. Okay, what's going to happen here? And so what are you going to be left with up top? Negative square root of 5. Okay, let's square first. When I square a negative, I actually end up with positive, but I still have this minus right here, so that's going to stay a minus. And when I square, what's the square root of 5 squared? 5. And this 2 squared is 4. Everybody understand that the square root went away? No, because this is going to end up being 1 minus, and this comes out to be a positive 5/4. Because when you square a negative, you get a positive. But what's 1 minus something? 1 minus a positive is the same thing as 1 minus. So really, it's this guy right there that stays. Okay, this part did become positive. Okay, these are very good questions. All right, so let's go ahead and work out the bottom. So this is going to become negative 5/4 divided by, just kidding. I don't know what I'm writing. Just kidding. This is going to become negative square root of 5. What's 1 minus 5 over 4? Negative 1 over 4? Okay. Negative 1 over 4. And so then I'm just going to simplify this one more time. And so a negative divided by a negative is a positive, and it's going to be 4 square root of 5, I believe. Yes? Over 1. So the tangent of 2x is equal to 4 square root of 5. So, yes, absolutely. So I heard this, like, I keep using my AD over BC trick. Could you just take it and multiply it by 4 to everything? And that's fine. So I hear that's what some people do. It's, ooh, yuck, gross, disgusting, nasty, you can multiply by a common denominator, just like a complex fraction. Sure. Because we are doubling it. And so when I double it, will I still be in the second quadrant? So I love this question. Everybody listen to this question. So you got to think about what we're doing here, okay? She said if we're in the second quadrant, what do we know is positive? The sign. We know the sign of x is positive, just the sign of x. So I want you to think about it. She said when we found the sign of 2x, we found it to be negative by the formula. So this is a great, great question. All students take calculus. We know x is in the second quadrant. And so yes, our sign right here for x, the sign is square root of 5 over 3, but what are we doing? We are then doubling it. So when we double it, where might it end? Say it's, I don't know, 100 degrees. Where might it end? If I doubled 100 degrees, where would I go? I would go to the third quadrant. Does that make sense? And so what ended up being positive? Out of all of ours, our cosine came out to be, did our cosine of 2x come out to be negative? Yes. Did our sine of 2x come out to be negative? What came out to be positive? Our tangent. Because, like, and if you think of it, does that make sense? Now, you could be in quadrant 3, so evidently wherever I landed, I don't know exactly what the degree was. Do you understand? So evidently I landed in quadrant 3. And that makes sense, because if you double, like, let's just say for 100 degrees and you double it, you would end up in quadrant 3. Could you be, like, right here and double it and end up in quadrant 4? Like, give me an easy example of something close to 180, but not 180. 170. So if I double 170, where would I be? 340. So would I be in quadrant 4? So when you, like, if it's an angle here, so really if you're in quadrant 2 and you double it, you're going to either end up in quadrant 3 or quadrant 4. Does that make sense? And that's why the formula, the double part of it, changes the sign of the sine, the cosine tangent. Does that make sense? So it won't always be like the sine's positive or negative. The sine's positive, cosine's positive, or I said that backwards. Sine's negative, cosine's negative, and tangent's positive. That's what we got for this one. Because evidently when we doubled it, I was closer up here, and when I doubled it, I ended up here. But it is possible to be in quadrant 2 and be closer to the 180 mark and end up doubling it and being over here. So when you are in quadrant 2, when you double it, you'll either end in quadrant 3 or quadrant 4. You won't end in quadrant 1. There's no way to double it that way. Sure.